Imagine electricity is water flowing through a pipe. The voltage is the pressure pushing the water, and the current is the actual water moving. A resistor is a deliberate narrowing of that pipe. It restricts the flow of electrical current, converting excess electrical energy into heat. Without resistors, your circuits would destroy themselves. They protect delicate parts like LEDs and microcontrollers from receiving too much current. Mathematically, resistors operate on Ohm's law, V equals IR. By choosing the right resistance value, engineers can precisely calculate voltage drops and bias points in a circuit. At the material level, fixed resistors use different construction types. Carbon film is cheap but noisy. Metal film offers tighter tolerances, and wire-wound resistors are designed to handle high-power, high-heat applications. Resistance is determined by the material's resistivity, length, and cross-sectional area. As electrons collide with the atomic lattice of the resistor, they lose kinetic energy, which is released as thermal energy. To read them, we use standard color bands, or SMD numerical codes. The first bands represent digits, followed by a multiplier, and a final band indicating the tolerance, which is the margin of error for that resistor's value.